A reality of growing any crop is you have to find some way to manage the weeds. Herbicides are most common, but can have problems with restrictions, resistance, and regulation. Tillage is also used, but is often insufficient and problematic for soil health. But what about zapping weeds with lasers? I know it might seem crazy, but Paul Mikesell says it works, and Carbon Robotics has the customers to prove it.
The laser weeder lets the onions grow without knocking them back from this herbicide spray, without knocking them back from cultivation, etc. So, that's a great boon for the farmers, more yield, more profit, etc. But also the inputs are lower. You need less fertilizer because in the middle of the onion growth, you didn't damage them and cause them to have to get stunted.
Carbon Robotics laser weeder has been used on over 100 different crops, but they're not stopping there. Paul has a background in artificial intelligence and sees an opportunity to leverage AI to provide more value in farm operations.
We are far enough along in the evolution of these AI systems that they can be bringing real insights. And I haven't seen that done well yet. So that's kind of our next big challenge is get to the point where we can actually demonstrate these kind of insights for farmers.
Carbon Robotics CEO Paul Mikesell on today's Future of Agriculture podcast. Hey there, fellow Ag Nerd. Thanks so much for joining me for another episode of the Future of Agriculture. My name is Tim Hamrich, and every week you and I get to hear from the founders, farmers, innovators, and investors, the people shaping the future of the ag industry. And just before we dive into today's episode with Paul Mikesell, I'd like to take just a moment to thank our quarterly presenting sponsor, which this quarter is Headstorm, engineering growth for the farms of tomorrow. Headstorm is a full-service technology consultancy with been there, done that knowledge and expertise in the ag industry. The team at Headstorm knows which digital strategies work and which ones don't work based on the competitive landscape across broadacre, specialty, and animal ag industries. Headstorm provides a holistic and actionable technology roadmap that bridges the gap between strategy and implementation. So from inception to execution, they help you play to your strengths, mitigate your weaknesses, and make technology your unfair advantage. Learn more at headstorm.com. That's headstorm.com. I'll leave a link for it in the show notes. And thank you so very much to Headstorm for supporting ag innovation and the Future of Agriculture podcast. All right, now back to today's featured conversation with Paul Mikesell. Paul is the founder and CEO of Carbon Robotics, and what Carbon Robotics is doing in and of itself is novel and interesting, and we're going to talk quite a bit about that in today's episode. But it's also important to note that Paul has a very impressive history of building and scaling and exiting successfully technology companies outside of agriculture. So this is a fun one to get not only the story of what he's doing, but also his perspective on the industry. Before starting Carbon Robotics, he co-founded, I hope I'm not getting this name wrong, Isilon Systems, a distributed storage company in 2001. Isilon went public in 2006 and was acquired by EMC for $2.5 billion in 2010. In 2006, Paul co-founded Clustrix, a distributed database startup that was acquired by MariaDB in 2018. Immediately before Carbon, Paul served as Director of Infrastructure Engineering at Uber, where he grew the team and opened the company's engineering office in Seattle, later focusing on deep learning and computer vision. So in today's episode, we're going to get to talk about laser weeding, of course, but also building a field robotics company and hardware companies in general, Paul's view on artificial intelligence and where he sees applications for that tech in agriculture, and the challenges and opportunities ahead for not only Carbon Robotics, but for ag tech in general. I'm going to drop into the conversation here where Paul is explaining what prompted him to want to make the jump from tech to ag tech and how that transition has been.
I'll tell you something about tech. It got pretty boring just watching people build more iPhone applications for this or that and, optimizing your marketing spend, right? Changing the world through, optimizing your marketing spend, right? That stuff gets very boring. And so it's time to start doing something real. And what's the new technology that I got very deeply involved in that I thought was going to be exciting for the future? It was these AI systems, specifically these deep learning neural nets that really understood the world around them. And I saw this in, self-driving car projects, etc. But there's a huge opportunity in agriculture to be helpful with this technology. And so that was kind of what kicked off the thought process. And then just meeting with farmers and realizing that there's a lot of opportunity. Farmers have a lot of problems that could be solved with this kind of technology, automation generally. And that the farmers were really probably some of the best customers I've ever worked with. Much more interesting than selling stuff into IT, traditional Fortune 500 or whatever. Working with farmers is amazing. So the product, the opportunity, and the customers.
And at what point during that process did the laser concept come up? Because it sounds like what interested you was the AI part, which is, kind of the detecting what's happening in the field. But why lasers and how did that come about?
The lasers was just, I knew how to do the AI part. As you point out, that's my background, my specialty. And the lasers was just trying a bunch of different stuff. If you're diligent about going back to first principles and thinking about what am I trying to accomplish and what are all the ways that you could accomplish that. We tried blades, we tried all kinds of stuff. So lasers was just one of the things on the list. And when I had it working and I saw how well it was going to work and I saw that we could make it accurate enough to work quickly, then that was really the starting point. And the thing that got me really excited by this was actually when I learned through some of our investors, some of our prospective investors, that they had asked John Deere what John Deere thought about this technology, and John Deere said it was impossible, that this was never going to work. So I felt like, well, great, I have this thing working that everybody thinks is impossible. Let's go, right? That was really it, and I think we've proven that out.
In this podcast, I specialize in really dumb questions that lead to smart answers, and here's the first one, perhaps of the day. I can't say that I could accurately explain to my 10-year-old what a laser is. I understand what a laser is from the Dr. Evil sense of the word, but not really what exactly is happening on this machine that's burning up these plants.
Yeah, okay. So laser stands for light amplification through stimulated emission of R. I can't remember what the R is. Maybe it's radiation. Think about this. You know how a spark plug works, right? You gap the spark plug, it creates a arc, and that's what makes your engine go if you have a gas-powered engine. Well, the laser itself is a much bigger version of that, running at very high voltage. And instead of jumping a gap through the air, like it does in your car, it's jumping a much bigger gap through some gas, okay? And in our case, it's CO2. And when you jump a spark through that, it creates a plasma. And that plasma has this property where it will keep amping up the energy rate as long as you keep the thing cool enough, right? So it will transition through these gas phases. That plasma in the middle is emitting light. And then all you do is you basically stick a filter on the end of it to keep it culminated, which means all the particles are going the same direction. That's your laser. That's how our lasers work. There are many kinds of lasers. We use these ones because they're cheap and they're part of another process. They're usually used for metal cutting, so easily available, etc. But the laser is just basically pumping energy into some medium and then getting light out the other side. That's the basics of the laser.
And so the farmer is driving this implement over a bed, and your computer vision is detecting every single weed and very precisely zapping it, for lack of a better term, with these lasers. What's powering the laser? Because it sounds very power intensive.
We get our power generation from a generator that we plug into the tractor PTO. And the whole point of the laser is that it's an efficient way of converting energy to light. It's an efficient way to do this, and that's why you see lasers used all over the place in metal cutting, like I said, and like skincare and all this other stuff. It's a well understood process. And the good thing about it is that it's so finely targeted, which means what you get is a nice tight beam that allows us to direct all of that energy onto the specific point we're trying to hit. So instead of just blasting out light all around, like these light bulbs above me that makes this ambient light, a laser specifically targets all that energy in one direction. That's how you get the beam. That's why it's called a beam or a laser beam. So what we do is we target that beam onto the meristem of the weed, the undifferentiated growth cells in a plant. It's called the meristematic cells. So we target onto the meristem where those cells are and explode all the cell walls, and then the plant dies. So the laser gives you high energy, intensely focused on a thin beam that you can target.
One thing we'll talk about here as we go along is your focus has been in vegetable crops and other specialty crops. And so I would imagine a lot of these units are going to the state of California, which is very concerned about fires and anything that could possibly start a fire. So I have to ask, why is there no risk of this starting a fire in a very fire-prone area like California?
Yeah, well, a couple things. So first of all, these laser weeders are pulled behind a tractor. So we do have an operator with every unit. They're 20 feet wide. So they do a reasonable amount of work per person. And we say that, it does the work of 70 people, a single laser weeder. These fields are well manicured as well. There's not a bunch of vegetative matter growing in the field. Everything in there was either planted by the farmer, that's a crop, or it's a weed that's coming up. And so we get in there and we kill these weeds before they come up. And so really what you're left with is just dirt and crops. There's not material there to ignite. This is not like a prairie that you're going into. These are well manicured fields. And you're right, we do sell a lot of machines into California. We also sell all around the country, in fact, and up into Canada. We have a number of machines in Europe at this point and Australia. So we are, in the last several months, have moved to a global footprint for carbon robotics and the laser weeders. And we pretty much have stuff constantly on boats heading to Europe at this point. And
is it all manufactured in the U.S. here?
It's all made in the U.S. here. Yeah, that's right.
And I know you talked about how other companies were saying hey, you can't do it with lasers. It's just not going to work until you figured it out. Is that something you're able to patent, where Carbon Robotics is the only one able to use lasers for certain purposes?
Yeah, we have a number of patents. We have 7 patents on laser weeding alone, and then several patents on other things as well. Yeah, it's something we patent, although I think we win because we have a better product. We have a great support team. We have the history of making this happen and making this work. And there is a lot that goes into targeting a laser onto a specific point while your machine is moving around. It's bumpy and dusty and dirty. And you've seen these fields, right? It's not exactly a pristine clean room out there. And so you really do have to go through a lot to make sure that you can target these things and target them well and consistently. And I think that's just a very difficult problem. And so you can try it and see, and you'll realize really fast, oh, this is pretty hard. And it took us quite a while to get there, So I think mostly what happens is people try it and then go, oh, this is really difficult.
Well, along those lines, now that you're out, you have units all over the world, essentially. What have been the big learnings along the way as this has been used in more and more context for more and more things? What have been we need to figure out this problem?
So our support team gets accolades consistently and constantly as being the best support that most of these farmers have ever had. Our uptime, is better than the tractors. There are days where the tractor is down and they're saying we wish we got the same support on the tractor that we got on the Carbon Robotics laser weeder. So I think part of that is hiring a good support team and making sure that you have people in the places where people need you is critically important in agriculture. You cannot leave your customers hanging. You have to treat this as if you're going to be there and make sure you're there for anything that the people who took a bet on you and believed in you early, make sure that they get amazing support. And then, as you grow the company, like we have, continue that great support experience all throughout the life cycle of the machine. So we try to be like Apple in that, the kind of support we give is supposed to be excellent and the best in the world, and makes people feel like we really have their back. So that's part of it. And then I think the other part, the learning that we had along the way that was a little bit depressing, was just how many of our vendors, right? Because we buy parts from other people. I'm talking about air conditioning units and things like that. How many of our vendors said they could do things and no problem. And then completely fell apart and could not do it. And it's kind of amazing how many people I don't know if they just basically lied to us or they didn't know what our expectations were going to be. That when we said we really do need this level of support, that we're counting on it. Yeah, I don't know. So there are a couple of companies who, I probably shouldn't name, but who I feel like did such a bad job that they should be ashamed. So we have to take over those scenarios there. And there are scenarios where I'm personally out there, especially during the early units, on top of the machine, wrenching on stuff and rewiring things in the field because some vendor screwed up. That happens a lot. So that was, I think the second learning was that, your vendors, you need to really test them and pressure test them, not just on the prototype they build you, but over the long term, and make sure that they understand, your expectations. And then I guess the third thing is really everything you build needs to be farm tough. And, we don't always get that right. And sometimes we have to overcome it with that great support that I mentioned. And so it takes anybody, I think, a while to get through far enough into the market to realize what actually is going to break and what needs to be hardened or, all of that stuff. So I think a lot of what I'm describing to you is kind of the like hardware into a farm environment life cycle and how to build something that can be sustained and give the growers their money's worth. So it's a combination of great support, iterating on the design and making sure it's farm tough, and then testing your vendors extensively and continuously.
Very interesting. Well, I don't want to get too into the weeds on like how to grow a robotics company, because I think that could easily become the focus. I do want to focus in on artificial intelligence. That's something that the whole industry is trying to like process, I think, and understand. Artificial intelligence, I know, is a very, very broad term. A lot of the conversations lately have been around more the generative AI, the sort of spotlight that ChatGPT has shown on the potential there for the large language models, et cetera. But with your background, I do want to ask you more about AI specifically. It sounds like the way you're using it now is sort of computer vision and machine learning to actually really precisely know where the weed is so that you can, zap it with the laser. What other applications out there for the technology, because you know so much about it, are you finding interesting?
Well, I think there are 3 areas that could be iterated on right now, and we're spending time on several of these. First of all, the obvious AI field robotics, right? That is, as you point out, computer vision, but also learning and planning activities in the field. So AI-based field robotics, okay? And then we have to get to the point that we can help digitize all these farm operations and then layer an AI optimization layer on top of that. So as a grower operation where you've got farms all over the place, around the country, maybe around the world, using AI to help optimize that system, there's a lot that could and should be done there. And I'm just talking about even predicting what crops you should grow where and harvest predictions and these kinds of things. And then the third thing is what we're calling AI optimized value chain, which has a lot to do with price prediction and demand prediction downstream from the growth areas. So I think all 3 of those things are going to become important. We've obviously made our name in AI field robotics, and we're starting to spend more time on farm operations because we think we have a lot to offer there. But AI generally is, I know there's a lot of confusion about it in the world right now. ChatGPT, I think, exposed a lot of people to the concepts and the power of it, but I know there's a bunch of confusion about it as well. The easiest way to think about it, I think, from a farming point of view is that what we're really doing is taking all of the data that you have and then letting a computer, or let's say forcing a computer to build up a set of sort of truths about that data, right? And those things are these higher level concepts that live inside the neural net. And that's why we can go from a couple hundred pictures of carrots to an AI that can detect carrots. It's because it's learning a sort of meta principle of what a carrot looks like. So we can apply that same philosophy and technology to farm operations and price prediction and all these kinds of things. Generative systems, as you mentioned, ChatGPT, is really, it's a similar kind of idea where the generative system, in the case of text, has been fed a bunch of sentences, a lot of sentences, and then words are removed from that sentence, and the model is supposed to predict the next correct word. So it's similar in concept, right? You're training on top of all of this data and forcing this computer to have this kind of higher level idea about what's there. And in the case of a generative model, any of the LLMs, the higher level concept is this kind of sentence structure and what the flow should be between the words preceding and what the next word most likely is. ChatGPT, I think, does a great job for a lot of use cases. For me personally, you wind up Googling stuff, and unless you use the right words, it doesn't show you the right result. And you may not always know what the words are. So something like a LLM does a great job of being able to translate between what your concept is, right, and what the actual search result would be. So we have a similar thing going on in our robots where we're translating between all of these other pictures that it's seen versus what's currently in the ground and figuring out whether or not that's a weed or a crop or something else. So those are kind of the similarities. And the general field of AI has been taken over by these neural nets, and that's what all of these systems are.
Makes sense. Yeah. Yeah, and I want to talk about you all starting to get into more the digitize and optimize part of AI that you talked about. And to me, that makes sense because, and redirect my thinking here if I'm wrong, but for this to all to be economical in agriculture, you need something that provides immediate value that can also serve as a source of data collection for things like that. You can't just say like, hey, let me just keep flying over your field every week and pay me for it, and trust me, you'll get the money back. It doesn't work that way. So it seems like what Carbon Robotics has is this laser weeder that's taking care of a problem I have today. I don't want to hire 70 people to be out there with hose. And in the process, you can start to collect that data. Is that why that's a natural transition?
Yes, that is perfect. I'm going to put that in my pitch deck, Tim. That was great. That's exactly. We started with a system that did something, and a byproduct of that has us taking all these pictures, understanding what we see in all those pictures. Next step is adding other sources of data into that same process and being able to show what's happening on a more global scale. And so we do have a data system right now that only pulls in laser weeder data. And we're going to start augmenting that with other sources of data input so that you can really get that same kind of AI system that's on the laser weeder operating across all your farms, all your ranches, all your fields.
And here's another dumb question that I'm hoping yields a smart answer. Where's the data go? I mean, where's that data all stored? And I imagine you're using this. I mean, in the crops you're working with, I don't know how many times a laser weeder goes over the same acre, but I imagine several. So over years of doing that several times a year, that's a lot of data. Where's all that data stored?
There's a lot of data. Yeah, so we have our own cloud infrastructure, and our agreements with the farmers, with our customers, are that we won't sell that data or use it for any other purpose than building good products. And so this is how we, can guarantee that somebody's not going to just buy it and learn everything about your farm or whatever. Our agreements state that it's only used for our own internal product development. And all the growers have been pretty great about, if you take pictures of my onions and you make a better onion model, that's good for everybody because everybody's doing that, right? So as long as we don't, show somebody's data to somebody else, it's cool, right? Everything's just going into this neural net. So we have our own cloud systems that do that. And over time, what happens is our neural nets on our AI systems on the robots, they learn which pictures that it's seeing are interesting. And interesting means different than something we've already seen. And we really focus the upload of those images to only being the ones that are interesting and new, where the AI could learn something new. And so over time, what that means is our models are getting more and more refined because we're picking out the areas where it hasn't seen something that looks like this before. And so all that data is going up into our cloud. And then we have an interface, a web interface that we call the Carbon Ops Center or Carbon Operations Center that you can log into and see all that data. You can see how many weeds we saw, what was the species, how many crops, what was the stand count, in a nice heat map format. We also have an API where you can pull it into your own systems. So a bunch of this stuff now is coming to fruition. And it's exactly as you pointed out. It's because we started with a laser weeder that is also a data collection machine. And there's value on top of that. So, but I think that's the right way to do it. You maybe were hinting at this, but there's been a million companies who said, oh yeah, we're going to fly drones and take pictures and show you all this great stuff. And how many of those are actually in use today? What great stuff did they ever show anybody, right? That's the problem is what are you trying to get out of this? And so I think because we started in the field and have been building up from there, we have a lot more insight into what's important.
Absolutely. Yeah, I think the intentions were there, which is like, yeah, if we start to collect the data, then we can find interesting things to do with it. But economically, it's just, somebody has to pay for this stuff. It doesn't make any sense.
Yeah, I hear this all the time. Farmers tell me they're tired of seeing data. They want insights.
Yeah, and even more so, they want outcomes, right? I think, for you, if I'm an onion farmer, you use that example. One thing I'm going to find really interesting is what you said about stand counts. So if I can get earlier stand counts, I can look out over my field and feel like, oh man, that doesn't look as good as it did before. I wonder if maybe I don't need as much fertilizer as I used before. If I could have exact stand counts, I could probably determine exactly how much less fertilizer I can use. Is that possible today?
Oh, definitely. Well, yeah, definitely, for sure. Yes, less cultivation, less chemicals. I'll tell you something else also. So we have all these pictures of onions. Onions is a good example of onion growth with laser weeder compared to onions with spray. And the spray knocks back your onions a lot, right? So these herbicides are really harming your onions. And so some of our growers are getting 20% yield increases, 30% yield increases because the laser weeder lets the onions grow without knocking them back from this herbicide spray, without knocking them back from cultivation, etc. So, that's a great boon for the farmers, more yield, more profit, etc. But also the inputs are lower because as you pointed out, you need less fertilizer because in the middle of the onion growth, you didn't damage them and cause them to have to get stunted, right? And so the fertilizer you put on that field is used for the onions and they grow nice and healthy and they don't get beat up in the middle of their growth cycle from dumping a bunch of chemicals on it. So the inputs are simpler, less of them. The yield is better. The stand count is better, right? Everything you can do to just get rid of the weeds and not have all these side effects contributes in a lot of ways. And the one you listed is exactly right. The fertilizer is more effective when you're not beating up the plant you're trying to grow.
We were talking about onions as a great example, and Mr. Onion Farmer himself, Shay Myers, is one of your co-founders in the company. Do you know how is the crop mix broken down today between like onions or lettuce or whatever else you're in? Is a majority of them onion farmers, or is it pretty well mixed throughout the veg category?
We do over 100 different crops, and onions is probably one of the top ones, but we have a lot of stuff going on. We do a lot of carrots, a lot of lettuces, a lot of leafy greens. Sure, onions is in there. We do stuff all over the place. We're doing some tulips, right? We're doing all kinds of stuff.
Well, I know in a lot of those crops, you have the entire gamut from a very small farmer all the way up to, Tanner and Antle or Taylor Farms, like some of the very, very, very big ones. Is there a sweet spot for carbon robotics, or is there kind of some limitations on where it makes sense?
The sweet spot has really been 800 acres or more. That's usually, we have some growers who are smaller than that, but most of our farmers are 800 acres up to 100,000, right? So we're kind of all over the place, but we definitely focus on more of the, well, kind of obviously, right? A farm that needs a 3-row machine and has enough infrastructure to keep it running. Infrastructure meaning tractor and people, tractor driver and things like that.
Yeah. Well, I like what you said earlier about, the tech industry has just kind of moved in this direction of like, how do we optimize marketing with this technology rather than, build interesting things that impact the world? That resonated with me a lot. The historical narrative is that it's a whole lot harder to scale in agriculture, though, right? Like, what has been your experience in trying to really grow and scale in ag versus the other industries you've been in?
Well, yeah, I would say anything that's hardware-based is harder. I don't know that it's ag specifically, but because we started with our AI field robots, our AI laser weeder, that's hardware. So I think in that sense, it's harder than a pure software company. But I will say that working with farmers is probably better than selling to almost anybody else for a piece of hardware, because the farmers, they always do what they say they're going to do. And usually when a farmer tells you, okay, if you can show me this working, I'll buy it, that's usually true. And, we try to be pretty straightforward with our growers. And, an example of that, we don't do discounts. We never have done a discount. We don't do discounts. Why? Because I want to make sure that everybody's getting treated the same. So I don't want to do, give some big farm a discount and have some little farmer have to pay more per unit, for example. So we just don't do discounts. What that means is when you talk to us, the price is the price, and there's no haggling necessary. There's no worrying about if your neighbor got a better deal or whatever. I think in this world, you can just be very straightforward like that. And that's different than even in hardware, selling hardware into IT, into other tech companies. They all expect these long, drawn out discount sales cycles and blah, 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 right? It's not fun. Those parts of the selling process are not fun. And so selling into agriculture is great. You just make a good product, you support it well, give all your growers an honest deal, try to treat everybody fairly, and you can be successful.
Do I remember correctly that you all started with like a self-propelled unit and then went to the pull behind the PTO?
We did. Yeah, we did. That was driven by a couple of different things. First of all, regulations. In California, for example, you have to have a person with every machine. So like, what's the point of an autonomous machine that has somebody with it? You may as well give them a chair, right? That was the big joke about like, what, at least give these guys a chair if they have to sit there with your autonomous machine. And then all the exception cases, and there's a lot of exception cases, center pivots, sprinkler pipes, like all kinds of things in the field that you don't want to run into. And after a couple of our robots almost got destroyed by some center pivots, we had to take a good hard look at, what's important. And we decided that what was really important was getting laser weeder out there, and that the autonomy was kind of a nice to have. And, our growers still ask for it, but it's kind of more of a nice to have than anything else. There are some autonomous tractors coming out now that we can plug into and then make the whole system autonomous. But the pull behind solution got us past all of these hurdles that were coming up with autonomy and allowed us just to really focus on what was important. If you look at some of the other folks trying to build other field robotics, most of them have moved to a pull behind now. And I think for similar reasons.
Yeah, no, it makes a lot of sense. And I was smiling as you were talking about the pricing transparency and one price for everybody, because I did an episode on Cyrus McCormick, the founder of the inventor-ish of the mechanical harvester, and that was one of his big things, is like absolutely one price for everybody, and really differentiated himself. And this was like 1800s, but it makes a lot of sense to me. It's how people want to be treated. They expect to pay a fair price, but they just don't want to pay more than everybody else has to.
Yeah, I mean, go try and buy a new car. It's like, what's going on here? Why am I arguing with the car dealer guy about, right? What are we doing? So now I got to worry, did I get a good deal or not a good deal? I got to call around all these dealerships and whatever. I hate that stuff. As does everybody. Nobody's a fan of it. So why are we doing that?
Right. Well, Paul, the show's called Future of Agriculture. Obviously, we're talking about stuff that is happening today. But as you project out forward, especially with your knowledge of artificial intelligence, how do you see the industry looking different in the coming 5 to 10 years as a result of this the rapid iteration of the technology?
Yes, we're going to get to a point where your farm operations center will look a lot more like NASA during a space shuttle launch than a bunch of people with clipboards. I think that's where we're going to go, is digitizing and automating a lot of this stuff so that it can be consistent, repeatable, so that we can help farmers get through all of these scenarios that come up with weather and price changes and crop failures and all this stuff. We need to be able to help predict what's going to happen and take action before it happens. And in order to do that, getting data into the systems, doing it in a way where it's meaningful and that you can show insights, right? And so we'll get to the point where these farms are optimized largely through the use of these computer AI systems to be able to not have these dramatic swings in, good years and bad years. And I think a lot of that's coming. We hope to be a part of as much of that as possible. And, part of it is just execution, right? Getting a machine that's farm tough, kind of like we talked about. But we are far enough along in the evolution of these AI systems that they can be bringing real insights. And I haven't seen that done well yet. So that's kind of our next big challenge is get to the point where we can actually demonstrate these kind of insights for farmers that have real action, right? That can help them do a better job, get better crops, higher yield, all this kind of stuff. It will be nice over the years when we see the weed seed bank drastically reduced because laser weeder has gotten in there and knocked those weeds down before they went to seed. It will be nice if we didn't have to use as much water just to deploy herbicides on a lot of these crops, right? So I think, there's a lot of environmental positive impact we can be having along the way also through this kind of automation and efficiency. And so all of those things are coming, and we need to be able to do it as a country to remain price competitive, right? We can't keep having crops, go to Mexico and lose our ability to grow our own food in this country. That would be a real travesty. And, the only way we're going to get there is through optimization, and optimization really through automation. I think that's the only answer. Doing more with less means optimization.
Cool. Well, Paul, anything else before I let you go, or anything we need to emphasize or add?
I don't think so. I mean, I'll tell you, I am a listener. I don't always pick up all of your podcasts, but it is in my rotation. I appreciate what you're doing for the industry and getting the word out there. There's a lot of excitement happening in agriculture. I want to continue to push on this idea that we don't all need to get, acquired by Deere for some super low valuation, that we do need some real strong standalone companies that usually goes through an IPO process. So that's where we're heading. I appreciate your support in our success in getting there. I think we can help set a good example for the industry, where we need to go in the future, long-term helping farmers, long-term getting more investment into the space, just doing good for everybody, the consumer, the farmer, everybody who produces and eats food.
All right. Well, that is going to be where we end today's episode. Thank you very much to Paul Mikesell for being on the show. If you'd like to learn more about the laser weeder or any of the work that Carbon Robotics is doing, highly encourage you to go check out their website, which is just carbonrobotics.com. I also want to thank our quarterly presenting sponsor this quarter, which was Headstorm. Be sure to learn more about them at headstorm.com. And last but never least, thank you for your time and your attention. I do not take it lightly. I'll be back next week with another story of ag innovation.